Those of you who have been following along with this power supply building business are probably wondering, what's going on here? What's the holdup on this power supply? Did it drop off the face of the earth? No, it didn't drop off the face of the earth. However, we did run into a glitch, and we're in the midst of solving it. Last time I told you that this little old transformer was too wimpy. It wasn't giving me enough voltage. So I went back to Radio Shack and I bought one like this. And this one's a little tarnished on the outside, but they're just identical transformers. And now we went from voltage too low to voltage too high. And it wound, as soon as I fired it up, it wound, the surge of voltage blew out my 1N4007 rectifying diode there. So we went ahead and stuck a 100 ohm 5 watt resistor between the output of the secondary here, the output of the transformer. Put the resistor between it and one side of the diode to kind of give us a little cushion there, so when this thing comes on, it just doesn't go bang and wipe it out again. We didn't want that to happen. Well, we're still running voltage a little too high, even after I hooked up the 6,000 ohm load to it again. So what we're going to do is we've decided to use what's called a Zener diode. A Zener diode. And I'll show you, let me show you that on paper what that is. A Zener diode looks exactly like a standard diode, except the symbol looks like this and like that. It's got a couple of little tails on it there. And this end will be down here hooked to ground. Or, there's other uses for a Zener diode. Let's say along comes the voltage, it's coming along pretty steady here and everything. And then all of a sudden, for some reason, it rises up. Or we get a fluctuation in it or something like that, which drives it beyond the 90 volt range. Well, I don't want, let's say this thing right here, let's say it's 120 volts. All of a sudden, this little spike right here, or these little rises are 100 volts each, or whatever may happen. It's above the 90 volts that we want for B plus on this radio. What we're going to try to do is come up with a steady output. So we install the Zener diode in parallel with the last microfarad, the electrolytic capacitor. We'll install that across the electrolytic capacitor like that. And now, see, this Zener diode is set for 91 volts. Like so. Now, the Zener diode acts as a relief valve, actually. If you push against a door hard enough, the door is going to bust open. Well, basically, that's what happens here. Anything above 91 volts will come diddy-bopping along here and pass all the way down through to ground. The diode, the Zener diode, will break over. It'll break over, just like the door busting open, and it'll allow the excess voltage to go and allow us to continue putting 91 volts out. Now, after, let's say, when things go back to normal again, in comes and everything's kind of nice, this thing does a little reset action. It goes back to what it was to begin with. And then it waits for the next spike or the next rise in voltage, so it can dump everything over 91 volts to ground. A relief valve. It'll be in parallel with C2 on our power supply, which is an electrolytic filter capacitor. Now, just so you know where we're going to be hooking it, Zener diode, we're going to be hooking it across these two terminals here, which will be in parallel with this last capacitor. Okay? One end will solder there, one end will solder there. Unfortunately, that's where the glitch comes in. I can't get a hold of a Zener diode at the earliest until the middle of the month that's rated at 91 volts and 5 watts. I need a 5 watter. I can get a 200 volt, I can get a 400, all kinds at Radio Shack where I live, but they're all, the wattage is 1 watt, half a watt, stuff like that. I need a 5 watt. And besides, they don't have a 91 volt, everything's too high. So I had to order it from DigiKey. And DigiKey says that's the only place I can find one. DigiKey says, hey, thank you for the order. Unfortunately, we don't have any in stock. Yeah, that's pretty good. My very first order with DigiKey, and they don't have it in stock. Anyway, first impressions mean a lot with me. Anyway, the earliest date they could give me, the earliest, is the 16th of April. So we're sort of stuck because I want to use that Zener diode. Anyway, meanwhile, one of my subscribers, Anton Babby, I think is the way you pronounce his last name, he said, John, why don't you get rid of this single diode here, this single rectifier diode, this 1N4007, and why don't you use an entire full wave bridge rectifier on it like you did down here? Why have that little old thing there when you can have be using both sides of the wave and of the electrical wave coming out of there? And it's, that makes sense to me. That makes sense to me. And so I talked that over with Brendan. He says, sure, go ahead. It sounds like a good idea to me too. If you want to stick one in, stick it in. Okay, so I'm going to put another full wave bridge rectifier in here and get rid of this single diode. And of course, again, the full wave bridge rectifier is a 4 amp jobby rated at 400 volts. And we're going to solder it up same way we did here. Same way we did here. The two center leads coming out of it will go to each of the black wires down here coming out of the transformer. The positive end here that's marked with a plus, it's exactly the same on this one here. Okay, it's marked with a plus, and it will go to the positive side of the electrolytic capacitor, and the negative side, which would be the other one down here, will solder to the negative side of the first electrolytic capacitor. Now we'll go ahead and leave this 5 watt 100 ohm resistor in there to cushion it. I don't want it to blow on me, so this will be hooked up exactly the same way. And now this one here, I think, it may be wrong, but it's numbered. No, it's numbered the same, negative, positive, with a couple of wave signs, in the center, sine waves. And then, so we'll get rid of this, put that in, and then we're going to wait around for the Zener diode. So let's go ahead and get this in. That's it. I have the bridge rectifier in. The two center legs go to the two black wires coming out of the transformer. The positive leg goes over and hooks to the positive side of the electrolytic. The negative leg, and they're labeled negative, positive, and then the two sine waves in the center. The negative leg comes around, hooks to the negative capacitor, and the one of the connectors coming into the AC leg, I put the 100 ohm 5 watt resistor there. Okay, so we're good to go until we get that Zener diode. And again, the Zener diode will go in parallel with C2, which is this black electrolytic. It'll connect here and here. And I hope I didn't confuse you all too much about this Zener diode business. Essentially, it's just a relief valve, an air or water, relief valve. The voltage comes along and gets too high. Anything that's too high is let through. The diode breaks down and allows it to go through. It's called an avalanche effect. And then after everything smooths out again, it continues on with 91 volts. It shuts back up and waits for the next one to come along that's too high. And that way we continue to maintain a 91 volt flow all the time. I hope that's clear. Okay, this weekend, nice and warm, nice and sunny. Time to get out and cook another cobbler outside over the open fire. No rain this weekend. So until next time, hopefully when the Zener diode is in, this is John.
Sometimes we all do things that, well, just don't make no sense.